Hi everyone. Since it's an online week this week, I just thought let me just record what we covered this week, record the lecture on what we covered this week. But I'll start from what we did from last week, okay? We're still on integration. We did integration by parts, and now it will be integration by completing the square. Math 2 integration is pulled from Math 1. Okay, so you need to revise your Math 1 integration because there are some problems which just need your Math 1 standard integrals. Okay, the integration formula sheet will be given to you. If you need a formula sheet, you can go to your study link under a study guide. You'll go to the page 55 toward the last page. You'll see the formula sheets. This is a formula sheet. It also includes standard integrals. These are Math 1 standard integrals formula sheets. And then there are Math 2 standard integral formula sheets. If you go to your link under study guide toward the end on page 55 to 57, you'll see the formula sheets. These are the Math 2 standard integrals formula sheets. It's a Z formula sheet. We use this formula in this section of integration by completing the square. Let's go back here. While we're still on Math 1 standard integrals, in Math 2 you learn about inverse functions, and now they ask you to integrate something like this. If you want to integrate like sine inverse of x over a square root of 1 minus x squared with respect to x dx. So this is just simply require Math 1 standard integrals. There will be some problems which just require your Math 1 standard integrals, okay? So let me start here. You still remember this formula number 1 in Math 1? When you integrate, when you integrate f of x, and then f of x is to the power of n, and then there's f prime dx. The integral of this form will be f of x to the power of n plus 1 over n plus 1. I don't know what's happening here. This formula, it's from Math 1. I assume you know it. When you integrate a function that is to the power of n, and that function that is to the power of n have a derivative outside, then which means you can apply this formula and evaluate the standard form of this integral and say the integral is just going to be f of x to the power of n plus 1 over n plus 1 plus c. And then if you were, because last week was not an online week, I did a revision. If you were present, I did some Math 1 revision. We also consider a special case when n equal to 1. What's happening with the formula when we n equal to 1? Let's see. It will be integral of f of x to the power of 1 because n is 1 times f prime dx, and then the integral will be f of x to the power of n. We said n it's 1, right? So it would be to the power of 2 it would be to the power of 2 if we substitute 1 here. 1 plus 1 is 2 over 1 plus 1, which is also 2 plus c. Because if we have this formula, we always look for the function that is to the power of n. But when n equals to 1, it's hard to see which function is to the power of n. But what you need to notice, whenever you have a product of two functions, and it happened that one function it's a derivative of another function, then it means it's still the standard integral of f of x to the power of n, but our n is to the power of 1. So you can use just this simple formula, and then the integral you say is f of x to the power of 2 over 2 and then plus c. Okay, let's go back to our problem. We want to integrate sine inverse. We want to integrate sine inverse over square root of 1 minus x squared dx. Okay. Solution. So what you notice here, when we integrate 1 over, we can write this as 1 over square root of 1 minus x squared multiplied by sine inverse of x dx. So what you notice here, we have a product of two functions. You know the derivative of sine inverse. Even this formula, if you need, I will give you. The derivative of sine inverse of x is 1 over square root of 1 over x. So it's like we have a product. If you let, maybe according to this formula, if you let f of x equal to sine inverse of x, and the derivative of this function is 1 over square root of 1 minus x squared there. You can even check the formula sheet. I know if you're going to need this, I'll provide you. And then you notice that if you let this to be f of x and there is a derivative of it, so which means you have this form. So it's when your f of x is to the power of 1. So you can just say the integral of this is just f of x to the power of 2 over 2 plus c. So because now here you have this form, f of x times f prime. F of x times f prime, the integral is f of x to the power of 2 over 2 plus c. So f of x times f prime, the integral is f of x. We said our f of x here, it's sine inverse of x to the power of 2 over 2 plus c. So again, I gave you exercises based on this. So as you know, in Med 2, you learn about the derivative of inverse functions, and you know the derivative of inverse function are algebraic functions. Derivative of inverse is algebraic functions. So not if you want to integrate like inverse function, it can be even hyperbolic functions. So if you're algebraic and they want the integral of that, so think of using this standard integral, okay? Because yeah, it can help you to be able to evaluate your integration. Okay, so now let's go to integration by completing the square. Integration by completing the square. Okay. In integration by completing the square, we're going to use this standard formula Z and A. So if your problem, you can able to put in one of these standard form, one of this Z standard form, you'll able to evaluate your problem, and these are the standard integrals of anything that is in this formula. So here you need to understand when to apply the standard integration by completing the square. So most common when you want to integrate maybe a constant, let's say a constant k over a quadratic expression, ax squared plus bx plus c, with respective to x, you can always take out the constant k and say the integral is 1 over your quadratic, whatever your quadratic might be, plus c dx. So if you have this first form, if you integrate a constant over a quadratic, you pull out the constant out and left with 1 over your quadratic. So in this quadratic, you completing the square. That's why we say integration by completing the square. So because in this quadratic, we need this quadratic to have 2 terms. So you can able to do that. You'll see the example by completing the square. So you have 2 terms, one term in terms of x and another terms in terms of a constant. Okay, so you know if you have this form, you'll apply the integration by completing the square. And another form that you look to know that you completing the square is when you have a constant over a square root of a quadratic expression with respect to x. Again, if you have a constant, you take out the constant, but you have 1, you find, and just say you have 1 over a square root over of a quadratic with respect to x. So always when you have 1 over a square root of a quadratic, just know you're applying the integration by completing the square. Again, you just taking your quadratic and complete the square and put this quadratic in terms of 2 terms. I'll tell you why we put in terms of 2 terms. Even here, we complete the square, it will have 2 terms. The reason why we're completing the square, we want to put our quadratic in one of this form. We say when after we complete the square, it will have 2 terms. So one term is in terms of x and another term is in terms of a constant. Okay, all of this standard integral is in terms of 2 terms. Even under the square root here, you see 1 over a square root, and after you complete the square in your quadratic, you will have 2 terms. One term, it will be in terms of x, so you choose z such that it's a function of x, or you'll choose that it will be the term that have x. And then a is always a constant, so you'll choose a constant. Once you put each term in squared, you'll choose a and z. But you will choose z such that it's a function of x, and a such that it's a constant. Okay, but you'll see example if you want. Okay, let's go back here. But you look for these forms. Okay, all these forms, it will tell you that you're using integration by completing the square. The last one, it's when you have integral of a square root of a quadratic. See, with respect to x, you know the quadratic form. This expression ax squared plus bx plus c. All these a, b, c are a constant. Okay, so what you do again here, you're completing the square under the square roots, and if you have a square root of a quadratic, just know you're going to apply integration by completing the square. Okay. Let me give you the easy example here. Integrate 1/1 plus x squared dx. You see here you have a constant. In this case, it's just 1 over a quadratic. So which form is this? If you check here, this is the first form. You have a constant over a quadratic. If you have any number beside 1, you can pull it out and have 1 over your quadratic. So quadratic is anything that is to the power of 2. If your expression is to the power of 2, highest power, it means it's a quadratic. So here we have 1 over a quadratic. Remember, your quadratic usually have 3 terms. Okay, 3 terms, as you can see. The reason for completing the square is just that to put our quadratic into 2 terms. Okay, but in this case, our quadratic is already in 2 terms. Okay, once your quadratic is in 2 terms, it means you now be able to use these standard formulas. This one, you just need to write your problems in one of the standard formula and see which formula you're going to use. Okay, here, after you're completing your square, if you need to complete the square, now is in terms of 2 terms. So in this case, we didn't have to put our quadratics in terms of 2 terms by completing the square. So we just need to use the standard formula. The way of using the standard formula, we need to choose what is z after you put your quadratics into terms, but this quadratic is already into 2 terms. So you write each term in squared in this quadratic. So x is already in squared. So this 1 in squared is still 1 squared. Okay, 1 is equal to 1 squared. Okay, so you always choose z such that it's a function of x that is in squared. The term that have x but in squared, you're just gonna choose z such that is in squared. So we can choose z to be x here. So when we substitute z here, it should be in squared as we saw the formula. Okay, so we also choose a such that it's a constant but in squared here. So this a can be 1. Okay, so always from z, find dz. Dz is dx. It's like when you derive dz over dx equal to 1, that over dx we cross multiply with it, so we'll see that dz equal to dx. So we just interested in finding dz. Just know when you have z equal to x, dz equal to dx. Okay, so as a part of the solution, after you choose z and a, please substitute them here in your formula just to see which formula you're going to use from the formula sheet. Okay, so we said 1 is a squared plus, we said this is z squared, and dx is dz. Okay, So after you complete the square, you choose z and a. You choose z such that is in squared in a term that is in terms of x, and a such that is a constant but also in squared, okay? And substitute z and a in your problem just to see which formula appearing here. So you want to integrate 1 over a squared plus z squared dz. This is already, you have a formula of this form. Go to your formula sheet. What is the integral of z a squared plus z squared? You see 1 over z squared plus a squared there. We have 1 over z squared plus a squared there. So the standard integral of this 1 over z squared plus a squared is equal to 1 over a tan inverse of z over a plus c. Yeah? Okay. Remember, you take the formula that have 1 over z squared plus a squared, not z squared minus or a squared minus. We take 1 over z squared plus a squared or a squared plus z squared. This is the only formula which say a squared plus z squared. So the integral of this, if we check the formula, we said it's 1 over a tan inverse of z over a plus c. Okay. All right. So we substitute z and a into our formula just to see which formula is this. So according to the formula, they say the integral of this is 1 over a tan inverse of z over a plus c. Okay. Now it's integrated. Now, if you go and we use the formula. So substitute back the value of a and z after integrating. We are only substituting z here into our problem just to integrate using a formula. Okay, so now we have our integral, so we need to substitute back z and a. So we said a is 1, so we're gonna have 1 over 1, which is 1 tan inverse of z is x over 1, x over 1 is x, and then plus c. So the integral of 1 over 1 plus x squared is tan inverse of x and then plus c. You know it should be like that because we define integration as antiderivative, okay? So when we derive this, we should get back this. Integration is a reverse process of derivative, okay? So when we integrate this, we get this. When we derive this, you should get this, okay? You know. This was a simple example. So now we're able to integrate 1 over 1 plus x squared dx, okay? The integral is tan inverse of x plus c. All right. Let me give you just example so you'll be familiar with these standard integrals. Okay. Example 2. The question will always say integrate. So you should know which technique you should apply. Eh? You already know when you integrate the product of two functions, you may need to use integration by parts. But now, again, if you have this form that I mentioned here, one of the three, if you have 1 over a quadratic as we did here, we have 1 over 1 plus x squared. You know you need to use integration by complete the square, okay? You didn't have this form in Mate 1, eh? So because now you know how to integrate by complete the square, and apply those formula, you'll able to find such integrals. Okay. So, okay, let me just give you more example on integration by completing the square. So, for example, let's say we want to now to integrate 1 over x squared plus 4x plus 2 with respect to x. So again, you have a constant over a quadratic. Okay. So you know you need to integrate by complete the square. So take your quadratic in the denominator, x squared plus 4x plus 2, and complete the square. So when you complete the square, most of you know this, I did in class. So you write the first two terms that have x and open a space and write your constant, that's 2, okay? You open a space here because we need to add some terms here. You add a half coefficient of x, a half coefficient of x in squared. So a half coefficient of x will be 2, half coefficient of x. Half of this coefficient. The coefficient is 4, a half of this coefficient is 2. But in squared, it will be 4. So you add 4 and minus 4. 4 minus 4 is 0. It's like we added 0 here. We didn't affect the value of our expression, okay? But the next thing, you'll take the first 4 terms and just factorize. So the factors of x squared plus 4x plus 4 is x plus 2 squared, okay? So when you factorize these first 4 terms, x squared plus 4x plus 4, it's x plus 2 squared when you factorize these 3 terms. And then now you have minus 4 plus 2. What is minus 4 plus 2? Minus 2, So now you see after completing the square, you will have your expression quadratic form in terms of 2 terms, okay, which is what we want. And then after you wrote your expression in terms of 2 terms of quadratic by completing the square in terms of 2 terms, write each term in squared because you still need to choose what is z and what is a. So what is 2 squared? 2 squared is square root of 2 squared. You see square and square root cancel, so you're gonna left with 2 and get back your 2, okay, when you need it. But we just need to write this expression in terms of 2 terms and both terms in squared, okay? So now we'll able to integrate this. So the integral of 1 over x squared plus 4x plus 2 with respect to x dx is going to be 1 integral of 1, and write this expression in terms of after you complete the square. So this will become this. So x plus 2 squared minus square root of 2 squared, okay, dx. That's your first step. Once you see you have a constant over a quadratic, just complete the square in your quadratic, and then you write in terms of 2 terms, and each by completing the square and each term in squared, okay? So from here, you'll able to choose z and a. I said you choose z such that it's a function of x in squared. So the term that have x is this one, but you choose z such that it's in squared there. So z will be x plus 2, all right? So we're gonna have z squared here because now you let this z. And a, it's a constant. You take from the constant term, but a such that is in squared, so a will be a square root of 2, okay? And then from z, find dz, it's a derivative of this, or it will be dx, okay? We just choose a and z such that we're going to substitute into our expression. So we'll see from the formulas that will be given to us what is the standard integral of this. Okay, so the integral of 1 over, let's put our expression in terms of a and z. So we said this is z, so it will be z squared minus, we said square root of 2 is a, but squared, and then we say dx is dz. Okay, we have this form now, integral of 1 over z squared minus a squared dz. Okay, so you go to your formula sheet and check the integral of this form. Integral of 1 over z squared minus a squared. Let's check the formula sheet. Integral of 1 over z squared minus a squared. Integral of 1, this one, 1 over z squared minus a squared dz. Dz, they're supposed to put dz and then we see 1 over, okay. So you see this is a standard integral number 24, all right? Standard integral number 24, if you're integrating 1 over z squared minus a squared dz is equal to 1 over 2a ln of z minus a over z plus a plus c. Always after integrating, you need to put plus c. All right, so you see now you're able to integrate this. You know the standard form of this. The integral of this is, if you check the formula again, always have a standard formula sheet because when it's similar from your laptop, or if you print out, the integral of this, if you check the formula sheet, is 1 over 2a ln of z minus a over z plus a, yeah? And then they said plus c. You see now we're able to integrate using the formula. So the integral of this is 1 over 2a ln of z minus a over z plus a, okay? So now we integrated our problems, so we need to substitute back our value of z and a back because we need to see what is the integral in terms of x. So we said a is square root of 2 and then z is x plus 2. Okay, let's substitute all these values here in our integrals. This is 1 over 2. A is the square root of 2 ln of z. Z is x plus 2, yeah? Minus a square root of 2 over z, which is x plus 2 plus square root of 2, okay? And then plus c. Yeah. So here, as you can check, the integral that we wanted the integral of 1 over, oh, what's happening now? The integral of 1 over x squared plus 4x plus 2. We completed the square in our quadratic, and then we choose z and a and substitute back z and a, and then we're able to see which formula is this. It helps us to evaluate our integration. So after integrating, we substitute back z and a. You just only this simple step there. So this is the integral of this 1 over x squared plus 4x plus 2. Okay, this integral, and then you're done. Full marks. All right. Let me give you another example. I'll give you 3 more examples on this, and then I stop. I'm done with integration by complete the square. You just follow the same steps, okay? or for example, all right, it's fine. This is example 3. Again, question, just integrate. We want to integrate a square root of 35 minus 2x minus x squared, okay? dx. A square root of a quadratic, is it one of the form that we're looking at in order to apply the integration by complete the square? Let's check if it's one of those 3 forms I listed below. You see, this is the third form, This is the third form. Also, again, when you're integrating a square root of a quadratic, you use integration by complete the square. The only thing that you need to complete the square in your quadratic and write them in terms of 2 terms, okay? So here we want to integrate. We want to integrate square root of 35 minus 2x minus x squared, as a part of your solution. You need to take your quadratic, 35 minus 2x minus x squared, and complete the square. So always when I complete the square, I want to make sure the coefficient of x squared is always 1. So we have minus 1 here, so we don't need minus. So we take minus out as a common factor. So it will be x squared plus 2x minus 35, okay? So I took a common factor of minus because in front of coefficient of x will be 1, all right? You see when I multiply negative inside, I still get this term minus x squared, but I write this in order of a quadratic. I start with x squared and then follow with this term, this as the last term. But again, if I multiply with negative into my second term, I will get this minus 2x, okay? And also when I multiply with this negative into my third term, I'll get 35, okay? So my aim was to just make sure this is in an order starting from x squared, x to the power of 1 and constant, and also make sure that the coefficient of x is 1, okay? So the next step, you're completing the square. You know the step of completing the square. You just write the first 2 terms and then leave the space because we need to add some terms and write the last constant there, which is minus 35, okay? So you write the half of the coefficient of x in squared. Okay, the half coefficient of 2, the half of this coefficient 2 is 1. Half of 2 is 1. But in squared, 1 squared is 1. So we add this half of this coefficient, but in squared. So 1 squared is 1. But when we add 1, we need to minus 1. All right. Okay. So go to the next step. From the first 3 terms, just factorize. When you factorize this, it will give you x plus 1 squared. You can check, you get these first 3 terms. We just factorize this. And the last 2 terms is minus 36 and minus 1 minus 35 and minus 36. After completing the square, when you took a common factor, you can multiply by this common factor, which is negative inside. So when I multiply by this, it will be positive 36 and minus x plus 1. You see we completed the square. Now our quadratic is in terms of 2 terms. So the last step is just to write each term in squared there because we're going to choose what is z and a. So 36 squared is, if you know exponent, it's 6 squared, minus x plus 1. Already this one will be always in squared, okay? So after you're completing the squared here, so instead of this in your problem, just substitute your function that is completed squared, okay? So let me rewrite this what is on top because I'm going to hide it now. So yeah, we want to integrate. What I'm doing now. We want to integrate square root of 35 minus 2x minus x squared dx, and the integral will become this. So we completed the square. After completing the square, this becomes this in terms of 2 terms. So instead of this, we just substitute this. So it's 6 squared minus x plus 1 squared, okay, dx. All right. So next, you need to choose what is z and what is a from those 2 terms. You choose z such that it's a function of x and squared, so it will be x plus 1, and choose z and a such that it's a constant in squared, so a constant, it's 6 that is in squared. And then from z, find this z, it will be dx. And then after you choose z and a, substitute them back into your problem just to see which formula you're going to use. We said 6 is a, you'll have a squared minus z squared because x plus 1 is a z, and dx is dz, okay? So, and check which formula is this, which will help you to integrate this form. From the formula sheet, we were looking for a formula which is a square root of a squared minus z squared. Square root of a squared minus z squared. So which formula is this? Start with a, yes. Integral of the square root of a squared minus z squared dz. So you see the formula is this one, okay? Don't make a mistake and choose the wrong formula. See, you have a square root of z squared minus a squared and square root of z squared plus a squared, but we need this formula which is a square root of a squared minus z squared. It is to make a mistake here, so make sure you choose the correct formula, okay? So here we're going to write this formula down. After integrating this integral will be this, okay? So yeah. So the integral of a square root of a squared minus z squared, according to the formula, is a squared over 2 sine inverse of z over a plus z square root of a squared minus z squared over a squared, and then they said plus c. I hope I copied this formula correct. Integral is b a squared over 2 is number 28, a squared over 2 sine inverse of this z. Okay, I copied it correct. So we evaluated now the integral of this form is this one, okay? Now that we integrated in terms of z and a, just substitute back your value of a and z, okay? After integrating, so your value of a is 6 squared is 36 over 2 sine inverse of z is x plus 1 over 6 plus z, which is x plus 1 square root of a squared 6 squared is 36 minus x plus 1. Our z is x plus 1. We substitute here, but n squared also, all over a squared. A is 6, n squared is 36, okay? And then plus c. So this is our answer. Yeah? So if you like, you can say 36 divided by 2, it will give you 18. Eh? Okay, so the integral of a square root that we want, the square root of 35 minus 2x minus x squared. We completed the square and write in terms of 2 terms and choose z and a. And then we check the formula. We see this is the formula. We're able to integrate this. And then after we choose z and a, and then we need to substitute your z and a back. Okay. Yeah. For you, I did this in class, but please, if you don't remember, try it. Integrate. Uh, 1 over square root of minus 1 over 3 plus 4x over 3 minus x squared. 30x. Take this example, this exercise. I first gave you as an exercise, and then I did in class as a solution. I gave you a solution to this, but please try it. Okay. Let me check if I still have time here. Okay, let me give you 2 more examples. This happens now. Okay. Example. Let's say we want to integrate just use this one. I hope I will be correct. I'm just creating a problem for my head because I can't see now where I left my notes. Okay, let's say we want to integrate 3 minus x over 9 minus 4x minus x squared. All right. So here you no longer have a constant over a quadratic. Okay? So in this problem, you have a linear over a quadratic. Toward the last section of integration by completing the squared, I was doing such examples when you have a linear over a quadratic, and another example, it was a linear over a square root of a quadratic. Okay, that was the only two form we added after integration by completing the square. So here, when you have a linear over a quadratic or a linear over a square root of a quadratic, you split your problem into two terms. So where the first term you'll apply your Mat 1 standard integrals, and then in the second term you apply your Mat 2 standard integration by completing the square. Okay, so here, if you have a linear over a quadratic, from Mat 1, the other term from Mat 1, we'll apply this formula from Mat 1 when we're integrating integral of f prime over f of x dx. It will be ln of f of x plus c. All right, and the other term, it will be as usual integration by completing the square here. You can apply this formula when the numerator have a derivative in the denominator. Then it means the integral will be ln of f of x plus c. All right, so I'm saying when we have linear over a quadratic, we want to find the integral of a linear over a quadratic, then we're using this Mat 1 standard integral, and from Mat 2 is integration by completing the square. Okay, because we're going to need this, we're going to use this, so from the numerator you require that to have a derivative of the denominator. So you can treat this as f of x and check if you're gonna have f prime in the numerator. If you don't have it, you just force in the numerator to have a terms that have a derivative of a denominator, because we want to have a derivative of the numerator over f of x. So let me do it like this. So let's consider Mat 1 first, because you're gonna split this into two terms. The first term, it's when you use this and this, require this to have a derivative in the numerator. Okay, so we treat f of x to be 9 minus 4x minus x squared. 9 minus 4x minus x squared. And if you check the derivative of this denominator function, derivative of this is 0 minus 4 and minus 2x. So the derivative of this is minus 4 minus 2x. And if you check here, you don't have a derivative of this, but you know now when you have a linear of a quadratic, you're going to split this into two terms, but you're also going to need this form and integration by complete the square. So in the numerator, you're going to need the derivative of this denominator. So in the numerator, we need the derivative of this denominator. Okay, so as a part of the solution, the first thing, you check the derivative of this denominator as I did here, and then in the numerator you force. So we want to force this derivative in our numerator. Start with the terms that have x have minus 2. So to have this term here, you need to multiply by 2. So what I can do here, I will multiply by 2 everything. I introduce 2, you see, because I need this term to have minus 2. I introduce that 2, keep that in mind. But when I introduce 2, I need to divide it by 2. So 2 divided by 2 is 1, but I still have the same thing here. It's just that I introduced 2, but 2 divided by 2 is 1. So I didn't affect the value of this. It's just that I'm forcing my numerator to have a derivative of the denominator. I started with considering this term which have x. The coefficient of x is minus 2. To have minus 2, I need to multiply by 2. That's why I introduced 2 here. So now this will be like this. Okay, This will be 1 over 2 integral. If I multiply this out, it's 6 minus 2x over 9 minus 4x minus x squared dx. You see, we have one term of a derivative. So the next thing is to have this term which have minus 4. To introduce minus 4 is up to you. You can take from this constant minus 4, or if you like, you can just add minus 4 here, and then if you add minus 4, you need to say plus 4. It's like you add 0. So whenever you force things, you introduce things. So if you introduce things, you need to make sure the value of the whole integral doesn't change. Okay, so that's why when I introduce 2, I divide it by 2. You know, with the constant I can do anything. 1 over 2 integral. So there's this 6, and I need minus 4 as a part of the derivative. Let me write like this. Okay, I'm coming to the numerator. So I rewrite everything here, separate, because here I need to have this term minus 4. I introduce minus 4. I'm sorry about this. What I was saying, I'm introducing the next term because we already find the second term, the first term. With this have x, so I need minus 4. I introduce minus 4 here, but if I introduce minus 4, I need to put 4. All right, 4 minus 4 is 0. It's like I added 0 here. It's just that I needed this minus 4 as a part of the derivative of the denominator, because I'm forcing the numerator to have a derivative of the denominator. Okay, all right. So now you see the numerator have a derivative terms of the denominator. This will be 1 over 2 integral. Okay, before brackets, let me just do it like this. This will be 10, because this 4 will be part of 6. 6 plus 4 is 10. And let me leave this derivative of denominator like this. 9 minus 4x . So here, now since we have a derivative of a denominator in the numerator term, you just split into 2 terms. You start by dividing the other term. You're just dividing the derivative with the denominator. Minus 4 minus 4x divided by 9 minus 4x minus x squared dx. And another term which is not a part of the derivative is also gonna be divided by a denominator. Okay, that's how I split it. So you see, I can still go back here if I add those 2 terms, because they have the same denominator. I can take one denominator and just add in the numerator. I will have this. Okay, I'm just splitting them. I'm taking a derivative of the denominator and divided by a denominator, and then term that's not a part of the derivative, I just also divided by a denominator in another term. Okay, so here, as you can see, I split it into 2 terms. And if you check when we're integrating the first term, we want the integral of all this. If we integrate, we have a constant of a quadratic. You know, if you have a constant of a quadratic, you apply the integration by completing the square. And here, when you're integrating, you see f prime over f of x. You already checked the derivative of this is this one. You integrate anything that is f prime when you're integrating f prime over f of x. The integral is ln of f of x plus c. All right. So you'll be able to integrate this. Before I integrate this, my first term, it's a constant. So I can pull out the, okay, it's a constant and just complete the square here. You can confirm this. I did complete the square here. When I completed the square, I got a square root of 13 squared minus x plus 2 squared. You can confirm you know how to complete the square. Now complete the square and check if you get this, because you know you have a constant of a quadratic. You need to integrate by completing the square. You know how to complete the square. I'll show you in above example. And here you know you're going to apply this formula. If you have f prime over f of x in the numerator, we have a derivative of the denominator. So as you can check here, the derivative of this is minus 4 minus 2x. Okay, but when I integrate, because I was focused on my first term, let's return the second term as it is, minus x squared dx. Okay, so now for my first term, we use the integration by complete the square. You choose a and z, a and z. So when you choose a such that it's a constant, your a will be a square root of 13 and z will be x plus 2. So you're gonna have 1 over a squared minus z squared. Okay, so if you check your formula sheet, that's have 1 over a squared, because you choose this to be a squared minus z squared. 1 over a squared minus 1 over a squared minus z squared. You see this formula number 25. The integral should be in this form. Okay, all right. So let me write the formula here. The integral of 1 over a squared minus z squared. We did something. So the integral is 1 over 2a ln of a plus z over a minus z plus c. So we want to integrate 1 over a squared minus z squared, because we're going to choose this to be a and this to be z. So the integral of the first term, we forgot, we pull out 10. So 10 would be still for the first term, you pull out the constant and just integrate. Yes. So we integrate the first term, we pull out 10 and integrate 1 over a squared minus z squared. Integral of a squared minus z squared is this one. So there will be a 10 that we pull out, and integral of this is 1 over 2a, right? But our a is square root of 13, which is a to the square root of 13. Ln of a plus z, our a is square root of 13 plus z, our z is x plus 2 over a minus z, your a is square root of 13 and minus x minus 2 when you minus x plus z. This is the integral of this form. When we're integrating 1 over a squared minus z squared, is going to be 1 over 2a ln of a plus z. We choose this to be z. A minus z, according to the formula, a is square root of 13 and z is x plus 2. When you minus x plus 2 is minus x minus 2, okay? And the integral of the second term is just f prime over f of x. The integral is from x from ln of f of x. So this would be ln of 9 minus 4x minus x squared plus c. This is the answer, right? This is the answer. Yeah. Okay, this was just a formula. This is the answer. You can multiply half inside. So if you have it would be 5 over 2 square root of 13 ln of the square root of 13 plus x plus 2 over square root of 13 minus x minus 2 plus multiply half in the second term, half ln of 9 minus 4x minus x squared plus c. So all this is the integral of this function. Okay, let's start it here. Okay. From this problem, we split this. We know we have a linear of a quadratic, so we know we're going to split this in terms of two terms. The first term where you use math 1, from math 1 we're going to use this if you have a linear of a quadratic, and the second term it will be integration by completing the square. Okay, so you know you're going to use this from you first start by consider your math 1 standard integral. So you just see from math 1, if you're going to use this, you're going to have a derivative of the denominator in the numerator. Okay, so just again you need to have a derivative of the numerator of the denominator in the numerator. So you find the derivative of the numerator of the denominator here. You find the derivative of the denominator here, which is minus 4 minus 2x. So you need to have the derivative of the denominator in the numerator. So if you don't have it, you just force the numerator. Start with the term that have x. So when in the term that have x, we have minus 2x here as a part of the derivative of a denominator, but we have minus x, so we're short with 2. That's why we multiply with 2, we introduce 2. And when we introduce 2, we divide it by 2. And then next step, we return half and just multiply by 2 inside. We get this 6 minus 2x, and then we're happy. So far we have one term of a derivative of this denominator function, okay, which is minus 2x. So next now we need this minus 4, okay. When you need this minus 4, we introduce minus 4. But when you introduce minus 4, just say plus 4. It's like we add 0, 4 minus 4 is 0, right? So, but the next thing now in the second step, we introduce the second term, constant minus 4, and then we set minus plus 4, okay? So, now derivative terms here of the denominator, and derivative of the denominator now. So, in the following step, we're adding this term a part of the derivative. So, and then we're ready to split this into two terms. In the first term, we're dividing a numerator which is not a part of a derivative of a denominator. It's 10 with the denominator, and then we take the derivative of a denominator and divide it by the denominator. So you see now when we integrate both terms, in my first term, I have a constant of a quadratic. I'm using integration by completing the square. When I'm integrating the second part, I'm integrating using maths 1, I'm applying this standard integral formula, right? I have f prime over f of x. I already checked the derivative of this is this one, okay? So next step was just doing integration that I know. When I'm going to use integration by completing the square, I complete the square. I said, sure, if you also complete the square, you're gonna get these terms, okay? And then now you see, you choose a and z. I choose my a to be square root of 2 and z to be x plus 2. And now when I substitute back, it will be 1 over a squared minus z squared, okay? According to the formula, integral of 1 over a squared minus z squared is this one. And the integral is in this form, so that's where I substitute a and z here in my integral according to this formula, okay? I said a is square root of 13 and z is x plus 2. I substitute everything into my formula, everything this. And plus this integral of f prime over f of x is ln of f of x. So ln of f of x is the denominator function according to this formula. So yeah, last step was just multiplying by half in both terms. So if I multiply by half, it will be 10 divided by 2, it's 5 over a denominator, and return everything and multiply half here. In my second term, I will have half ln of 9 minus 4x minus x squared. If you are absent, please try this, but I did also this in class. Integrate x plus 2 over square root of x squared plus 9 dx. This problem I did again. I said if you have a linear over square root of a quadratic, you split this problem in terms of two terms, where the first term use maths 1 standard integral, this one. This formula, if you need it, I'm going to provide you during the test. The integral of this is to the power of n plus 1 over n plus 1 plus c. All right. And then you're going to split this in terms of two terms. That's how, and next term it will be integration by completing the square. Okay. So how do you simplify this? You treat f of x as x squared. Just to give you a hint. You take f of x as x squared plus 9 and check the derivative with numerator is 2x. Okay. Let me split it for you. So iterative of a quadratic under the square root is 2x. So in the numerator, you need to have a derivative of this. So in the numerator, you need 2x, so I need to multiply by 2. So after I multiply by 2 in the numerator, we multiply by 2, but we need to divide it by 2. And see if we divide the numerator with 2, we're gonna get back this numerator. But the nice thing, we have a term in the numerator which have a derivative of what is under the square root. So once you have a derivative of this function, you're ready to split this into 2. So split the derivative with dividing the denominator 2x over square root of x squared plus 9 plus 4 over square root of x squared plus 9. Okay, as you can see, you will still gonna get this if you, because they have same LCD denominator, you can just add the numerator and get back this. But the next thing here, you can able to integrate both there. You know, when you integrate this derivative of this function is 2x. So to integrate the first term, just take the denominator to the numerator. It's to the power of minus half. It's to the power of minus half. And second term, we have a constant over a square root of a quadratic. It's integration by completing the square. So I just gave you a hint here. You'll be able to integrate this. So you see, when you're integrating the first term, you have a function to the power of n, and outside you have f prime. So derivative of the f of x. So I said one time you will be using this formula. When you have f of n to the power of n and this f of x have its derivative here, you just say the integral is this. Okay, so you see now in the first term you have a function to the power of n, and the derivative of this is this we checked here. Okay, so you'll be able to integrate this using this formula. And two, we have a constant of a quadratic, a square root of a quadratic, and then that quadratic already have two terms, so you don't need to complete in the square. Just choose z and a and go to the formula and check which formula you want to apply here. So yeah, continue with the next step from here. All right, please do the examples, the exercises from a study guide, and be well prepared. Maths need a lot of practice. This is the end of integration by completing the square. Just do the exercises, okay? And then please always ask long understanding corner. All right. Thank you. The next lecture that I will do is integration by partial fractions. Okay. Thank you.